Hello all, welcome to the session on artificial intelligence in chemistry. In this session, we will look at how AI can be used in chemistry and various other aspects of using data science for chemistry and its allied sciences. Now, in this session, this is going to be a introductory session where we will look at how we can use artificial intelligence, data analytics, and the data that we get from various chemical reactions into making meaningful insights so that we can perform a lot of things that were impossible 10-15 years ago. Now imagine discovering a drug. Usually it takes several years, but now we are able to discover new drugs within weeks. Or maybe imagine finding a new material that absorbs carbon from the atmosphere or carbon dioxide from the atmosphere, making the environment more happy for us to live. Now, these you might think are like science fiction movies, but thanks to AI, all these have become a reality now. If you look at this, chemistry is a central science. It connects physics with biology, it connects material science with computational engineering, and there are a lot of things that we can combine to make meaningful insights. Now, in this session, we'll not be looking at chemistry as such, but what we'll be looking at, we'll be looking at how we can use AI and data analytics and how we can use the data to make meaningful insights from the domain of chemistry. So if you look at it, we will be looking at a lot of things, right from what is data, how we capture the data, how we load the data, how we process the data, and how we clean the data and then use this data to make meaningful insights. This could be running simulations in chemistry, or this could be creating visualization for molecular chemistry, or we'll try to predict what will be the temperature that you achieve from a chemical reaction. Now, you all would have seen in your chemistry classes that you can actually do titrations and find out what is the amount of a particular chemical needed to achieve a particular reaction. Now, previously doing these things, you actually go to a lab and you take the notes, you write how to do it. Now, with AI in picture, all these have become much more easy, much more accessible. To begin with, I'm going to start with a simple demonstration of how AI can be used for a particular chemical reaction. Okay, so now what we will see is, we will see how we can use ChatGPT to create certain chemical reactions, or maybe how we can do a particular chemical reaction. Now, to begin with, I'm going to say, take the role of chemistry expert and provide the details of estimating the strength of oxalic acid using the titration against KMNO4. Now, this is maybe this is a lab experiment that you will be doing in your lab. Now, when you have to do this, you will have certain steps. What are all the steps and procedures to be used, and how you have to do? What are all the equipments needed? What are all the apparatus needed? All this you will have to make a notes. Now, with the use of AI, right? This is an example of how we can use in chemistry. This is just a use case. Now, I'm going to say, I'm going to run this now. I'm going to prompt. So this is a prompt that I'm going to give in ChatGPT. Now, you will see how it basically comes up with a detailed explanation of estimating the strength of oxalic acid with titration against potassium permanganate. See, I only gave KMNO4, but ChatGPT, the generative AI that we have today, is able to understand that, okay, KMNO4 means potassium permanganate. And now it clearly comes up with all the steps for doing so. It says to determine it comes up like how you write your lab manual, right? So you write your lab manual like this, right? To determine the strength, what is the objective, right? Then it says, then it gives the chemical reaction for it, right? Like how you write in your lab notes, it gives you the chemical reaction. Then it gives you the list of materials that are needed for it. So I need oxalic acid, for which I don't know the strength. Then I have the standard solution, KMNO4 solution. Then what is the dilution that I need, and what are all the equipments that I need, right? Glass rod, white tile, distilled water, Bunsen burner, water bath, all these things it has given. It has also given us the procedure. Now, how do I do that? Okay, so you say wash and rinse your burette with KMNO4, rinse the pipette. So it has given all the steps, right? Now it is exactly like how, then it has also given a table for you to take care of the observations, and once you have got the observations, how do you do the calculations? Then it has also come up with what are all the precautions, right? So it has clearly told you how to do a particular experiment, right? Now you can also ask, I mean, now this is the beginning. From here you can make it much more interesting, or maybe you can say, you can ask a question, make this into a PDF for the lab manual. Now it starts making the entire thing into a portable PDF document, which you can use as a lab manual. Now I'm not saying that it can be used for students, but teaching professionals or lab instructors who are going to use this for your lab manual creation, or maybe you want to create a standard set of procedures. For all these things you will be able to do this. Now you can see that it has created, okay, unfortunately it has created a PDF file. I asked for it created a Word document, although I asked for a PDF document. But anyways, nevertheless, we have got a document for this. So you can imagine various possibilities that can happen. Now do not just consider this course for AI for chemistry. Now in this course we will be looking at how to actually do data analytics. How can we use tools like generative AI to make data analytics, or maybe prediction or classification. These are all various machine learning techniques we will learn throughout the class. So this is just an introductory demo that I want to show you how AI can help in chemistry. Now this is not a chemistry class by any chance. We will be tying up all the concepts of data analytics, data science for the domain of chemistry. How we can use the data analytics or machine learning or AI. Maybe later in the course we will look at how we can predict the molecular structure using convolution neural networks. So we cannot directly go into doing that. So we need to understand what is convolution neural networks. Now before that we need to understand what are all various types of data. So this course covers all the things that are needed for anybody who wants to do data science, machine learning, and also use it in the domain of chemistry. So do not think it is only for chemistry. We will be looking at various examples. We will be looking at various types of data throughout the course. So this is just an introductory point that I want to cover on how you can use AI for chemistry. Now coming back to our the presentation. So as we discussed, AI is used for drug discovery, finding out the protein structures of new protein structures, or finding out new materials, simulating all these things. Now a recent breakthrough was in 2024, the Nobel Prize for Chemistry was awarded to Demis Hassabis and John Jumper of Google's DeepMind for their groundbreaking work on AlphaFold. Now you can go to Google and type AlphaFold. Now there is a free website available where you can see about various protein structures. Okay, so this particular breakthrough that they have done, basically they are able to predict the three-dimensional structure of proteins from their amino acid sequence, which usually has not been addressed in the last 50 years. They were able to do it in a very less number of time. So idea is the AI or data analytics or data science, whatever you would like to call, provides you a great potential to be applied to any department of science, or maybe even accounts, or maybe to the literature, or it could be your day-to-day life. Like for example, you're using Google Maps. So Google Maps helps you to tell you how long it will take you to reach a particular destination. It is again data science. Or maybe I have a reactor. Now in the reactor there is a reaction that is going on. So you have conducted a reaction for, let's say, half an hour, and over the time you have noted how much is the temperature that it is increasing. Now with whatever data you have, you will be able to find out over the time what will be the maximum temperature. You don't have to actually do the experiment. You can ask AI, or you can train an AI model to predict what will be the temperature if I ran the same experiment for another 2 hours or another 2 days, right? So all these kind of things is possible when we connect any science like chemistry with data analytics, data science, and machine learning. Now why is this very important? Why is this AI for chemistry? One, as I already said, it helps you in doing faster discovery. It helps you to, instead of what it takes a year or what it was taking a month, now those kind of activities are now being done at a very fast rate, and we are able to get deeper insights. For example, you have a log. Let's say there is a log of data that you have got it from a chemical experiment. Assume that you are doing a chemical experiment and it is connected to a computer, and the computer notes down all the data. It could be the reaction rate that is happening, or the temperature, or the gases that it is releasing. It could be any data. Now that data is collected by your computer. Now when I assume that this is a very long experiment, maybe you're doing it for several weeks, and by the end of the reaction you want to understand the patterns, right? You want to understand some outliers in the data, or you want to understand when a particular temperature is increasing, whether the reaction rate is increasing, or there could be so many things that you want to come up with. So you will be able to understand new patterns from the data thanks to big data. Whatever be the size of data, maybe it is in petabytes or zettabytes, you'll be able to analyze this data much faster. And also it helps in experiment optimization. So instead of doing the actual experiment with the actual chemicals or actual devices, you can actually simulate them. You can simulate them and see what is going to happen. Once your simulations are satisfactory, then you can go and do the live experimentation. Again, because of doing a lot of simulations, you are not doing the actual experiment, thereby reducing the pollution, thereby reducing the temperature, global warming. And as you know, the world today is going towards sustainability. So having AI used for various chemical reactions, by simulating them, you are helping the globe to be much more livable. We are reducing the pollution as well as reducing global warming. Again, as we discussed, the learning AI as a chemist or as a chemistry expert, learning AI will help you in doing a lot of things. Like for example, you have a new research paper coming up, and you want to understand how this particular, you want to understand the research paper in a much quicker way, right? You don't want to read the entire paper. Assume that you have a research paper. You don't want to read the entire research paper. You want to quickly understand or learn the insights of this paper. So let us see an example of how AI can help you in understanding a particular research paper much easily. Okay, so now what you are looking on your screen is something called as Notebook LM. It's a Google product. Now this will help you to understand the research insights from a particular paper. For example, I'm just going to upload a source, right? So here I have a paper, okay, and I'm just loading this paper. Right? So the moment I've loaded this paper, now there are several things that you can do. What you can do is you can ask the entire paper to be made into a podcast. It will give you a podcast. Now this basically says visible light photosynthesis for chemical conversion. This is the paper. Now I want to know, I will ask, explain this paper to 12th grade student. I write this. I say explain this paper to a 12th grade student. Now this is basically what we call it as a generative AI. Now in this, what it is trying to do is, it is reading the paper, right? It is trying to convert the entire paper, and it has come up with a very simple explanation. It is saying what is photoenzyme. Okay, it is explaining that. Then it says how do these photoenzymes work, the problem with previous photoenzymes. Okay, and it comes with so it is coming at this particular paper. They are saying we are introducing a better sensitizer called thioxetane, and it is trying to say how it is useful. So from the paper, it is able to give insights. And if you look at the bottom of the screen, it is suggesting what questions to ask. You can see at the bottom of the screen, it is also suggesting what questions to ask. Now imagine all this you could do. It is not just for chemistry, it could be applicable to any particular domain. If you have content, if you have data, then you will be able to do a lot of things much easier without putting a lot of effort. So you could basically save all your time and energy for doing more creative things than doing mundane tasks like going through the entire paper. Again, I'm not saying going through the paper is a bad idea. It will help you in understanding the things much better. But when you don't have time, when you want to do a lot of papers, when you want to compare multiple papers. So here I could also add 10 different papers, and I can ask them to compare, right? What is this paper saying as compared to what is that paper? A lot of things we could do. Or maybe I could upload all my lab manuals, okay, and come up with and ask a question. Are there any outliers in the data? Are there any data points which are odd, which are not regular data patterns? So these kind of questions can be asked, and this is all free tools. Now you have this, all you need is a Google account. So if you have a Google account, you will be able to do several such things. Now, so coming back to our the slides. So what AI can do is, it can help you in whatever you have been doing. You can do it much faster. It will be, you will become 10x times or 20x times your actual capability, given that you are able to understand how this works. So in this session, one of the important things that we cover is how these things actually work. Okay, how machine learning works, or how data analytics work. I mean, what is the background for all these things? To some extent, we'll be covering all those aspects also in this particular class. Now, these are all some of the use cases when it comes to chemistry, drug discovery and molecular design. Reaction prediction. So AI predicts the products of organic reactions to the best reaction pathways. Example, we have transformer based models. Now ChatGPT is a transformer based model, right? Like there are several transformer models, and one of such transformer model is called the molecular transformer, which can predict the outcome of complex chemical reactions. And going forward, it can help you in designing catalysts. You all know that in order to make a reaction faster, you need a catalyst. So based on the past data, if you already have the data about various chemical reactions, you can use these reaction data that you have, and it can help in identifying or designing new catalysts to speed up the chemical reactions with less energy input. For example, as I said, machine learning models optimize metal organic frameworks, MOFs, for gas capture and catalytic performance. Again, you also have something called as material discovery. Now there are a lot of EVs coming up. There are going to be a lot of new batteries coming up. So when there are new batteries coming up, there could be new materials that might be needed, right? Right now they are using a set of materials. Now what if you want to bring up a new material, right? So these kind of AI use cases will help you in creating new materials or discovering new materials. You can't create it, but you can discover new materials which will help in producing eco-friendly batteries, or it could be eco-friendly materials for your rooftop, or materials that will absorb less amount of heat, which are less weight. All these kinds of things is now possible with AI. And there are also other uses like spectral analysis and interpretations. For example, IR cameras. Now you have IR cameras which basically help in diagnosing diseases, right? An infrared camera can help you in diagnosing diseases. For example, there are researches going on how to use infrared cameras to detect breast cancer or even oral cancer, or maybe any inflation, right? All these kind of things is now possible, but just the IR camera is not sufficient. You need the IR camera to take the image, but once the image is created, then you would need tools like the convolution neural network. In this course, we will understand what are convolution neural networks, how do we use them, how do we implement a convolution neural network. All these kind of things we will look at it. We'll also look at there are also also look at how CNNs help in classifying the molecule compounds. Suppose you have lot of materials and you take microscopic images of these materials and you want to classify them. Such kind of classification is also possible using CNN models, and they are also used in environmental chemistry. Now, in recent news, you can take a look at the website URL that I have given. So there, what they have done is they wanted to identify for a medicine, right? They want to identify a chemical which usually takes around 6 months, but they did it in 6 hours, right? So that is basically the power of AI, right? So how we can use it. So all these things, why I have given you a heads up, is basically to help you understand or acquire interest on how AI or ML or data analytics is helping us in various domains, including chemistry. Now, if you want to become one such professional, right, you want to use data analytics, you want to use AI, you want to use machine learning for chemistry, for your chemical experiments, for your simulations, for analyzing the data. So you have done a large experiment, you have a lot of data, and you want to find out patterns, you want to detect anomalies, you want to find correlation, or you want to find out outliers in the data. How can I do these things? Where should I start? Now, this is where we have to understand where do we start. So in order to become an expert for using ML, AI, data analytics for any domain, in specific to chemistry also, first we need to understand data and data types. What are all the different types of data we have? What are all various formats in which we will get data? And what are all the various data types? Then we will explore data analytics. Given the data, how can I do data analytics? How can I create a graph? How can I find out if there is a correlation among the data? How can I find out if there are a lot of missing data? Or how can I find out if there are some data that is outliers? Or how can I find out what is the relationship between one particular data column and another particular data column? How can I find out to what distribution a particular data belongs to? So we need to explore that aspect of it. Then we will see how do we visualize the data. Now, given a data, how can I put it as a bar plot? Or how can I put it as a line chart, right? Or a line graph? Or how can I create a box plot to find out the anomalies in the data or outliers in the data, right? How can I generate new insights from this data? Given the data, if you have a tabular data, you will be able to understand, okay, I have this data, but how can I generate new insights? Okay, if this is happening, this is happening. Or if this particular thing is happening, this is not at all happening. So how can I explore the data and come up with new insights? Then we will look at something called as inferential statistics, where we will statistically prove an intervention. Suppose, assume you're doing a chemical reaction, and during chemical reaction, you introduced a new catalyst. Now, how do you statistically prove that this particular catalyst has actually increased the rate of reaction, or how it has not increase the rate of reaction. Or not only that, any kind of interference that you are giving, or any kind of catalyst that you are providing, how is this actually changing the course of my experiment? How do you statistically prove it? You cannot simply come and say, hey, I use this particular compound and it increased the rate of reaction. You cannot just like that tell it. Though you could draw a graph and show that, see, it was going as a straight line, now it has suddenly become an exponential graph. You can do that, but if there is a small change, a small delta change, but you want to statistically prove that this has actually had an effect on the experiment, then you will have to do something called as inferential statistics. Then we will use machine learning. We will learn a lot of machine learning techniques like prediction, classification, clustering, basically to predict. So for example, you have data, you have created an experiment for, let's say, 10 days, right? And at the end of 10 days, you want to predict what will happen on the 15th day or what will happen on the 20th day. These what we call it as machine learning models. So these machine learning models will help you to predict, right? Or the next thing, which is prediction, is what is going to happen in the future. But prediction basically talks about numbers, right? So today the rate of reaction is this much. 10 days from now, what will be the rate of reaction? As of now, the temperature is 15 degrees centigrade. After 2 hours, what will be the temperature? So when you are trying to find out, or when you are trying to forecast a number, then it basically is a prediction. Then what is classification? So classification is basically, will this experiment succeed or fail? Or will this give is this a organic element or inorganic element? Okay? Or is this a poisonous gas or is it non-poisonous gas? So you are trying to classify. Given the data, you are trying to do a classification. An example is, for example, I give you an X-ray image. From the X-ray image, can you tell does this guy has COVID or not? Okay, so you are trying to classify. So when you are trying to classify, yes, no, maybe, or or let's say true, false. So these kind of things, what we call it as classification. Then you have clustering. So I have lot of elements. I want to know what are all the elements that are behaving alike. I want to cluster them. Then there is something called clustering. Then going beyond machine learning, you will go into something called as deep learning, where we perform advanced tasks. Like for example, you have a laboratory notes. From the laboratory notes, you want to find out certain insights, right? Or you want to find out whether the reaction was positive or negative. So given a large text, from the text you want to find out if there was, if it was a positive reaction or a negative reaction, or what are all the, so you have a large laboratory notes. From the laboratory notes, you want to simply find out what are all the chemicals used or what are all the apparatus used. So you'll do some advanced AI tasks like using natural language processing. Finally, we will go one step beyond the machine learning, what we call it as deep learning model, to perform advanced tasks. For example, you have lab notes or a large set of notes which have been written on a paper, right? And you just want to take a photograph of that and from that convert that into a text. Or maybe from the image, say, let's say you have an image, and from the image you want to find out if the reaction is completed or it is still in progress. So all these kind of advanced AI tasks, what we call it as computer vision or natural language processing, are all the things that we will start. So if you look at this course, we will start with understanding various data formats. Then we go on to understanding various data types. Then we'll explore data analytics using various tools. We will try to visualize the data. Then we will generate insights from the data and do exploratory data analysis. Then we'll apply what we call it as inferential statistics to prove if our interventions are actually making sense. Then we go on to do machine learning, where we do predictions, classifications, clustering, and finally we go on to advanced AI tests. Now all these topics, what we will do is, we will take some data, we will run our experiments, we will try to learn. and then we will also connect all of these topics to chemistry. How this can be used for chemistry. So we will not directly start applying them to chemistry. We will first learn the concept. We will do some exercises. We will show some demos, and then we will try to apply it to the chemistry. Okay. So one of only prerequisite for this course is that you need to have interest. Once you have interest, once you have the interest to explore, learn, you should be able to do it. So in this course, we will be teaching you various tools for data analytics, various tools for machine learning, various tools for AI. We will also be teaching you Python with respect to data analytics. Though we might not cover the entire Python course, we will cover all the aspects of Python that are required for data analytics. So we do not assume or we do not expect you to learn Python before it. If you know it already, it is well and good, but we don't expect. We will also start from the very basics, very much with respect to data analytics and machine learning. Also, we will be looking at various Python packages which are specifically designed for conducting chemistry experiments, chemistry visualizations, chemistry simulations. All these things we will look at it. We will look at various data sets that are available in the field of chemistry. Use these data sets to do data analytics, machine learning, and AI. So this is all about this particular course. And from the next session, we'll be looking at the basics of understanding the data types. Thank you, and I will see you in the next session.